Good morning, Chem 20s. So today is Wednesday, and this is our super short week. We just have 3 lessons. So today's lesson, what I'm going to be doing is kind of reviewing what we've already covered on our modified arrhenius definition for acids and bases. The reason I'm reviewing it and covering it a second time is this is probably one of the most important topics that you will use again, this skill in Chem 30. We use this for an entire chapter in Chem 30, the reactions of acids and bases in solutions, mainly in water, but with others as well. So it's really important that you have this one dialed in. So today we're going to be doing this review material with a short assignment at the end. And then tomorrow we're going to look at strong and weak acids and bases and wrap up the chapter early next week because, again, there's no classes on Friday with grad coming up. So pretty short lesson. Well, shortish lesson today, short assignment for sure to follow up. Okay, so grab your notes, get ready to rock and roll, explaining acids and bases. Here we go. Okay, so we've already done this definition. According to the modified Arrhenius definition, an acid is any substance that can react with water to produce hydronium ions. And remember, hydronium is H3O plus, and we always write them aqueous because they form in water. So a classic example would be hydrochloric acid reacting with water. And if you want to show the proton transfer, you can put a little arrow like that with an H plus. So the H plus is leaving the acid, joining water, and when you add an H plus to an H2O, you get H3O plus. So there's our hydronium ion and the anion that's left over. So this is where we get pH from, right? When we do our calculations, the higher the concentration of hydronium, the more acidic, the lower the pH. Remember, it's that inverse relationship. As hydronium ion concentration goes up, or you become more concentrated hydronium, your pH goes down, more acidic. So this is a classic example. And as a little side note, hydrochloric acid is a strong acid. So that means it does this basically 100%, acidically 100%. So strong acids will react with water and all of their molecules will react. So if we had 3 moles per liter of HCl, we would get 3 moles per liter of hydronium because of that complete reaction. And there are only 6 strong acids that do that. Okay, so that's acids. So you should be able to do these predictions. We're going to do them together. If you're feeling confident, you can try them on your own and then come back and watch the video to see if you got them right. Remember that if I'm calling it an acid, that means that it will react with water to make hydronium. If it is an ionic compound, before you react it with water, dissociate it, break it into its 2 parts, and then the more positive will be the, well, I guess that's not true. The one that has the hydrogen in it will be the one that donates to the water to make hydronium. So first compound is hydrogen iodide or hydroiodic acid. Aqueous hydroiodic acid, HI aqueous. Okay, so this is not an ionic compound. It's just a molecule. So we're going to react it with water. Just to make sure we understand, we'll show that H plus leaving the acid and joining the water to make our hydronium. So again, that's why it's an acid. If HI loses its H plus, then we have I minus left over. Charges are balanced. So this is a neutral molecule, a charge of 0. Water has a charge of 0. Over here we have a +1 and a -1, which equals 0. So we started with 0 and we finish with 0. So we say the charges are conserved in an acid-base reaction, or in an acid or acidic or basic reaction. Okay, now this is an ionic compound. So here's an example. We're starting with an ionic compound that has a metal. So we're going to dissociate first into its 2 ions. So we get an Na plus and an H2PO4 minus, 2 aqueous ions. Now you look at those and go, okay, well, which of those is the acid? If this is an acidic compound, so it would be the one that has the hydrogen to donate with water. So now that this is freed up, the H2PO4 minus will react with water. And you can show that transfer of an H plus. We do this in Chem 30 all the time. So if it loses an H plus, so let's do our math here. And we're just going to call this thing HX minus. And it lost an H plus. So if it lost a positive charge and it was already -1 and it lost another positive, it becomes -2. So what's left over here after we make our hydronium is it's lost an H. So we're down to H1. It was H2, so now it's H1. PO4, and it was -1 and it's lost a plus. So it's 2 minus. Now let's just double check our charges on this one. So we have -1 and water is neutral. So on the left, we have a total of -1. On the right, we have a plus and a 2 minus. +1 minus 2 is -1. So our charges are conserved. So we got the charges right. So H2PO4 minus turns into HPO4 2 minus and a hydronium. Okay, I'd like you to pause the video and try this one on your own because it's just like the previous one. It's an ionic compound. Dissociate it first and then react the hydrogen ion with water and then come back and see if you got it right. Okay, Na plus aqueous, HSO4 minus aqueous. There's our two ions. Put a little arrow in there, 100%. Now we want to take the HSO4 minus, which has that proton that it can react or give to water. And we get our hydronium. And the tricky part is the charges. We're at HSO4 minus, and we're going to lose an H plus, so we become SO4 2 minus. And we'll double check those charges. So we had a -1 and a 0, and we're at +1 -2, which is -1. So charges are balanced. Good. I put the last one in here because this one is tricky. So if I told you that carbon dioxide is acidic, you'd be like, there's no hydrogen in there to donate to water. Well, you're right. So we're going to react this one with water. This is a little different, and that's why I'm showing you this. I wouldn't expect you to figure this out on your own. This is a formation reaction. So what does it form if we slam those two molecules together into one bigger molecule? H2CO3. That is carbonic acid. So there's where the acid comes from. Now H2CO3 can now act as an acid, donate a proton to water. So what would the products be? Neutral and neutral. So in the end, we'll finish with neutral. So we're losing, well, let's make our hydronium, H3O plus. H2 becomes H1CO3, and it lost a plus, so it becomes minus. Let's just double check those charges. So neutral, neutral, +1, -1 adds up to 0. Charges are balanced, so we got it right. So this is an interesting one. When you put carbon dioxide into water, you make carbonic acid, which reacts with water to make it acidic, and the pH drops. And this is what they do with soda pop. And this is why soda pop is acidic. This is why carbon dioxide gas, when it goes into water, lowers the pH of pop. And some soda pop has a pH around 4, 4.5. And you're thinking, holy smokes, pH of 4 is very acidic. Yeah, it's hard on your teeth. It can corrode the enamel on your teeth, which leads to tooth decay and cavities. And then you might be thinking, well, wait a minute, acids are sour, so why isn't pop sour? Well, that's because they put a ton of sugar in it to mask the sour flavor, and you get that nice sweet-sour combo and the fizziness of the carbon dioxide gas. So that's where the joy of pop comes in, from the production of carbonic acid. I know, it's amazing. Chemistry is everywhere. Okay, we're almost half done our lesson. So now we're going to look at bases. Similar idea. modified arrhenius definition for bases. Substances that can dissociate in water to produce hydroxide ions. So they may just break apart and have a hydroxide ion, or bond with water, stealing the H plus and leaving the hydroxide. And remember, it's the hydroxide that gives you the basic properties. So the rule is if it's ionic, dissociate it first. And so the first example that we have here is an ionic compound, calcium hydroxide, and we're just dissociating it 100%. And we get calcium and 2 hydroxide, and that's where the basic properties come in. If we have a high concentration of OH minus, that means we have a low concentration of H3O plus because they are opposites. One goes up, the other goes down, and that means the pH will be high, okay, which means basic. Okay, so now let's take a look. Example number 2 is tricky. So this one is an ionic compound, Na2CO3. Breaks apart, we get 2 Na plus and a CO3 2 minus. So when you do this, the rule for ionics, you can add this to your notes. The rule for ionics is the most negative anion attacks water to remove the H plus. And that makes sense when you think about it, because if you have, the more negative you are, the more likely you can pull on that H plus and rip it from water. So you can see that example here. This 2 minus goes after the H plus in water, because remember, you can think of a water molecule as being made up of an H plus and an OH minus with a covalent bond. So the CO3 2 minus pulls on that H plus, rips it from water. So if water has lost its H plus, it forms an OH minus. The CO3 2 minus gained the H plus and becomes HCO3 minus. Let's just double check the charges on this one. So we are at 2 minus and neutral. So overall we're at 2 minus. And over here we're at 1 minus and 1 minus, 2 minus. Okay, so charges are correct. We probably did everything right. So that's a trickier one. That's an example of dissociating an ionic compound and then taking the negative anion and reacting it with water to make a basic solution. So we're going to go through 4 examples, and then we're almost done our lesson. Okay, first one, NaOH, ionic compound. It's got a metal in it. Dissociate it. Na plus and OH minus. There we go. That's why it's basic. It makes hydroxide. We're done. That one's a good old-fashioned high solubility, dissociates 100%. Okay, NH3 is not ionic. There's no metal in there. It's molecular. So molecular compounds react with water. So this one's a little tricky. So our rule, there's no anion in here. It's just one compound, but we know that it has to steal the H plus to make it basic. So if NH3 steals the H plus, the water is left with OH minus. There's the basic part. And what happens to NH3? It becomes NH4. A lot of students will stop there and forget about the plus. It gained an H and it gained a plus. Check our charges. 0, 0, minus 1, plus 1 adds up to 0. So those are the correct compounds. So ammonia and water makes hydroxide and ammonium ions. Basic. Okay, next one. Na2SO4 is ionic, so we'll dissociate it. Dissociate 2Na plus, aqueous, and an SO4, 2 minus, aqueous. Okay, so which of those will react with water to steal the H plus? The anion will, so SO4, 2 minus, will go after water's proton and steal it. Like that. Okay, so water's lost its H plus, OH minus. And SO4, 2 minus, has gained the H. So HSO4, and it was 2 minus. It gained an H plus, so now it's 1 minus. Check your charges. We have 2 minus on the left, and we have 2 minus on the right. I'll just dial those in for you. So there's a 2 minus and a 0, 1 minus, 1 minus, 2 minus. Okay, NaCN. Na plus and Cn minus. Okay, and you all know by now it's the Cn minus that will go after the water to make a basic solution. Okay, so steals the proton. HCN and OH minus. There we go. Basic solution. So that is the modified Arrhenius definition for acidic and basic compounds, how they react with water or in water to make acidic and basic compounds. One small topic left, neutralization. So neutralization is a reaction between hydronium and hydroxide ions to produce water. That's one way to look at it. The definition that you've seen before is an acid reacts with a base. So more sophisticated is looking at the acidic part, the hydronium, and the basic part, the hydroxide, to get water. And that's why it's called neutralization, because hydronium and hydroxide produce neutral water molecules. Okay, so that's sort of a standard definition of an acid-base neutralization reaction when we're taking the active, acidic, and basic parts. That's it, ladies and gentlemen. I told you, short and sweet again today. What a nice week for you guys. I only have one question for you to do in your textbook, number 4, page 253. So there's 7 of these to work on. So I want you to show how they can act as an acid or a base, and you're given a hint by looking at the pH to tell you if it's an acid or a base, so then you know how to react it with water. Is it going to steal a proton from water, or is it going to donate a proton to water? Is it acting as an acid or a base? So there's a little bit of thinking here, and this is a really good review activity for you. When you're done, then you can come back to the video and you can check all of the answers are right there. Okay, good luck. Hope you find this a little bit interesting. I like doing the math part of it, and I like checking the charges to see if I got everything correct on my formulas. Okay, all right, have a good day, everybody, and we'll see you for your last lesson of the week tomorrow.